a sophomore at Pace University. My major is forensic science, and I'm going to show you how to do a substitution reaction with alkanes. So we're going to start off with 1-methylcyclohexanol with hydrogen chloride. So our 1-methylcyclohexanol, it contains 6 carbons in a ring. So we're going to draw that with our methyl group and our alcohol. And then we're going to draw our hydrogen chloride, like this. So the first thing we do is show our unpaired electrons on our oxygen. So we draw 2 little dots. And then our partial charges on the hydrogen, which is a partial positive and then a partial negative on the chloride. So the first official step is to have the nucleophile, which is oxygen, attack the hydrogen directly. And to do that, we show it by an arrow. So we have an arrow going from the oxygen to the hydrogen. And since it attacked it directly, it forms a bond. And since it forms a bond, we need to break the bond between the hydrogen and the chloride. To do that, we also draw an arrow going from the bond to the chloride, showing that it's pushing the electrons to the chloride. So then that brings us to our next step. We draw our cyclohexane again with our methyl group, but instead, this time of drawing our alcohol, we're going to draw a water, since it formed that bond over there. And since it formed the water and it got protonated, we have a positive charge on the oxygen. And since the oxygen is positively charged, it doesn't like to be, so it wants to become neutral. So to become neutral, we need to break the bond here and throw the electrons there. And the reason we do this is because water is a good leaving group. We would not have alcohol over here leave because it's not considered a good leaving group for alkanes. So we have this leave, which forms our redetermining step. So our next step will form our alkane again with our methyl group, but this time, since the water left fully, we have a carbocation here, which is a positive charged carbon. So we draw the positive right there. And then we also have our byproduct from this step right here. We have our chlorine anion. So we have that here. And the carbon does not like to be positive either. It wants to be neutral. It needs to have 4 bonds. So to have that, we have the chlorine anion come in and directly attack it right there. And when the chlorine atom directly attacks it right there, we form our cyclohexane with our methyl. But instead of in the beginning with the alcohol attached, we have our chlorine attached now. So we have our chlorine there with our water as a byproduct. So this all forms an SN1 reaction. And then we can also name our product when we do an SN reaction. So it will be 1-chloro, 1-methyl, cyclohexene. And it's considered an SN1 reaction because at the redetermining step, our water is leaving at a separate point than our chlorine is coming in to attack. So I hope you enjoyed my lesson on substitution reactions for alkane, and thank you for your time.